Hey everyone, welcome back to my channel Data Mine Insight. So today we are going to discuss about the circular queue program. If you want to get in-depth video about queues and how circular queue works, then check out my previous video on circular queue. I already gave the link in the description box. And if you don't want to miss out on future videos, hit the subscribe button and become part of our Data Mine Insight family. So before we start with program, let's recap how circular queue works and why need to have circular queue. So let's get started. So let's take a recap about circular queue. So as you can see here, we have inserted 5 elements in our queue from position 0 to position 4. So where is our front? Front is at 0th position and rear is at 4th position. These are two variables and please don't get confused. These are not pointers, these are variables. So we have enqueued 5 elements in our queue from 0th position to 5th position. Now we cannot insert more element in our queue into linear queue. Let's suppose we have dequeued 2 elements, which I am denoting here with red color. We have removed 2 elements from this queue. Now I wanted to insert more element in the queue. In the linear queue, we cannot insert more elements because the size of queue is 5 and we have already inserted at the very last position of this queue. We cannot insert more element into this queue. But as you can see here, we have 2 blank positions at index 0, at index 1. We are not able to use these two positions in linear queue because in linear queue you cannot restart your queue from 0. You need to insert element at the end of the array. So once we want to insert element at these positions, then we have to use circular queue. So how circular queue works? Circular queue works on a circular movement. As you can see here in this circle, first we have inserted 0 1 first position, then second position, third position, fourth, 5 6 and 7. Then after we just have to insert element if this position is blank. Now let's take an example. We have inserted 2 elements in this queue. First is at 0 position, second is at first position. Where is our front? Front is at 0 and rear is at 1. Next we have inserted all the elements one by one. First 1 2 3 4 5 till 5. Where is our rear? Rear is pointing at the last position and front is pointing at 0 position. Then we have dequeued 2 elements. Now we are left with 2 spaces, 0 and 1. Index is blank. In circular queue we can utilize these 2 spaces as well. How we will do that? As you know that whenever we are inserting any element inside the queue, then we are increasing our rear. Now once we have inserted one more element on the blank space of our queue, then we have to increase our rear and rear has to be on 0th position. Let's suppose if I have inserted one more element inside the queue, then we have to increase our rear position. So guys, you might have these questions given below. First is how to check queue is full. Next is once at the end of the queue, how to begin. So let's answer how to check queue is full. As you can clearly see here, where is our front? Front is pointing at 0 and where is our rear? Rear is pointing at the very last element of our queue. So this is the clear case of queue fullness, or we can say that queue is full. So here we are checking that where is our front? Front is, if the front is at 0 and rear is at size minus 1. Size is 5, so 5 minus 1 is 4. So if this case comes up, then we can say queue is full. Let's suppose we have dequeued these 2 elements from this queue at the 0 position and at the first position. So in the circular queue, we can insert more element from the starting point as well. Like we can insert or we can just move our pointer from 4th position to 0th position. So we have inserted one more element, or we have enqueued one more element in our queue at 0 position. Now can you say that the queue is empty or queue is not empty? So we can say that queue is empty because we are pending with one more element. We can insert one more element in this queue. So now we have enqueued one more element. Now if you observe here, where is our rear and where is our front? Rear is just behind our front, and you can say front is just ahead of rear. This situation comes up, then you can conclude that this queue is full. So here we have to check one more condition. If front is equals rear plus 1, whenever our front is just after our rear. Now let's discuss the another question. Once at end of the queue, how to begin? So let's enqueue using simple hack. So we have a very simple formula over here, which is rear plus 1 modulo size, and we have to assign the value to rear. Let's insert elements in our queue one by one. So at the very first point, when you want to insert element inside the queue, you have to check whether the front is at -1. Definitely. What is the size? Size is 5. Rear is at -1 and front is at -1. So front is -1, then front would be initialized with 0. Now, in order to insert first element, we have to follow this formula. Rear, what is our rear? Rear is -1. So we have inserted -1 here, +1, +1. Now modulo by 5. So what would be the rear value? Rear value would be 0. So last value for rear is 0. Now again, if I want to insert one more element, now the same formula I have to follow. What is the last value of rear? It is 0. 0 plus 1 modulo 5. Here now rear is 1. Now what is the last value of rear? If I want to insert one more element, then we have to consider last value of rear. I have considered 1 plus 1 modulo 5. Here now rear is equals to 2. The same way we have to do until we reach the end of the queue. Let's suppose you are inserting the last element inside the queue. So how you will do that? The last value of rear is 3. 3 plus 1 modulo 5. Here rear is at 4. Means our rear pointer is pointing at the 4th index of our array. Now I just want to insert element at the 0th position. Let's suppose we have dequeued elements and now just wanted to insert more element inside the queue from the starting position. Now we have to follow the same formula. What is the last value of rear? Rear is at 4. Now we have inserted +1, means 4 plus 1 5. 5 modulo 5. Here now rear will be at 0. So using this formula, where is our rear? Rear would be at 0th position. And I just want to insert, if I want to insert one more value after this 0 to 1, how we will do that? We will follow the same methodology like step 1, because rear is 0. So now we have to follow the same 0 plus 1 modulo 5. Here now rear would be at 1. The same way we have to calculate. So now you got to know that how enqueue works. The same way we have to dequeue using simple hack. The same formula we have to use with front variable, front plus 1 modulo size. So what is a front value? As you have seen here, once we have inserted the first element inside the queue, then we have initialized front by 0. So whenever we are just dequeuing, what is our front value? Front value will be 0. Front is pointing at 0th position. If you want to remove or dequeue the very first element, then you have to follow this formula. So what is the front? Front is at 0. So 0 plus 1, 1 modulo 5. Here now front is at first position. So here you can imagine that where is our front? First position. Now we have to iterate the same formula again. 1 plus 1, which is 2 modulo 5. Here is now front as would be at second position, means over here. You can follow the same formula if you want to dequeue the more element. Now let's start programming. We have to include stdio.h, include.h. Now we have to define, I'm gonna define size by 5. So I'm initializing my items with the size we gave, which is 5. Now what would be the front value? Front would be at -1, rear would be at -1 as well. Now we have to implement one function which will check whether our queue is full or not. So for that I'm gonna implement full. So I already told you how to check that. So first we will check where is our front. If front is equals rear plus 1, or if front equals 0 and rear equal size -1. If this condition gets true, means our queue is full. So we will return 1, else we will return 0. 1 means we are returning as true, 0 means we are returning false. We will check is empty, whether our queue is empty or not. So if front equals the same way we did with the linear queue, we will do it with circular queue. then we will return 1, otherwise else we have to return 0, means it's false. Next is we will add element inside our queue. So how we will do that? We will check void enqueue, or we are going to take element in this function. So whatever element they will pass, this will come inside this variable. We are inserting, then we have to check whether our queue is full. If the queue is full, we cannot insert more element into it. So is full. If it's returning true, then we have to print f slash n and closing the inverted quotes. So here we are checking whether a queue is full. In the last slide, I've told you that whenever you are inserting the very first element, then initialize it with 0. Alright, then rear, we have to implement that formula which I told you, like size. Alright, so at the beginning, what would be the value for rear? Rear would be -1, then we have to increment by 1, then modulo size, and then we will just initialize this variable again. Let me give brackets over here. We have to insert element. I'm just printing message. Whenever I'm inserting, I'm just printing some message over here. Next is dequeue. So whenever we want to remove element from our queue, then we can use dequeue. Removing element from queue. So we have to initialize element. In order to remove element from queue, there has to be some elements as well. So in order to check that, we have to use is empty function. So if the queue is empty, and we have to just give message queue is empty, and I'm just returning -1 from here. What does this statement means? This statement means from item array we are returning front position. So where is our front? Front we have, once we have inserted element, our front is at 0. So we have removed the very beginning value of our queue, means whatever we have inserted at the very first time, that would get returned. Let's suppose our front is equals rear, which means we have both pointer at the same position, means this is the last element inside the queue. Just reiterate the queue. Else if this is not the last element in our queue, the same formula we will copy and paste over here. So this formula you have to copy and paste. So here just need to replace front, delete, or dequeuing element %d. So let's discuss this function one more time. So at the very beginning, we are just checking that if the queue is empty, then we cannot remove any element from this queue, and we are just printing this message and returning -1. Else here we are checking if integer. So because we are returning values, so we have to, there must be a integer type function. So let's suppose if the queue is not empty, then what we need to do, we need to remove the very first element, because our front, once we have inserted the first element inside the queue, front would be at 0. So we have returned the 0th position, elements from the 0th position. Then I'm checking here that if front is equals rear, means queue has only one element, so we reset the queue after dequeuing it. So we are just resetting over here. Then after, if let's suppose a front and rear is not equals, then what we need to do, we need to implement the formula we just discussed in the last slide, and we are just printing the message that delete element. That's all. As you know, this is the entry point of our program. Can you guess the output? Now you can see the output, queue is empty. Let's insert something inside the queue. For that, we have to use enqueue. First I have inserted 1, and see the output. Inserted 1, 4, and 5, here 5. So as you can see here, we have inserted 5 elements. Now I have inserted 6. Let's check it. So you can see here the queue is full because what is our size of queue? Size of queue is 5. So we have already inserted 5 elements. I just called dequeue function. So we have deleted element 1. Now I just wanted to insert the element inside the queue, the 6th element of the queue. What would happen if I want to insert one more element inside the queue? So you can see here queue is full. So whenever you want to insert more elements more than size, checking over here, so it will check if the queue is full, front is equals 0, rear is equals size minus 1. But this time this is checking this one, like front is rear is equals rear plus 1, because we have inserted 5 elements. Then after we have removed one element, means 0 position is blank. Now we have inserted this element at the 0th position. So that's all guys. Thank you. Hope you enjoy this video. It would be great if you just subscribe and like this